Very often, the kind of information that we have, especially in a real life situation, is such that the slope is not immediately obvious. We need to figure out the rate at which our function changes as our independent variable changes. So how do we go about doing that? Let me give you an example of the kind of information we might have and need to find a slope from. And then we'll see how to go about finding that slope. Suppose a company purchases a piece of equipment for $18,000. It's expected to fully depreciate. To depreciate means it loses its value. It's expected to fully depreciate in 10 years. And we'd like to use a linear model to describe its value after t years. And also then we'll want to say, what does the slope represent? So we want to describe its value after t years. We want to describe the value as a function of time. So the value depends on time. How do we do this? How do we find out the slope? Well, I'm going to make a table similar to the one that I made before, with t on the left and v on the right. We know that when they initially purchased the equipment, it's worth $18,000. And then 10 years later, it's lost all of its value. So now its value is 0. Okay, so we know that in the equation, the slope is going to be multiplied by the value of t. To find the slope, we take the change in v over the change in t. Because then when we multiply that by the time, the change in time, we get back the change that we want to have in v. Adding that to the initial value of v, we get the value of v at any particular moment. So, two things to be aware of. We use change in v in the numerator, t in the denominator, when v is a function of t. There's probably a slope formula that you're already aware of, that you're very familiar with, that I'm going to relate this to in just a moment. And if you are very comfortable with a slope formula that you're already familiar with, you can absolutely use that method. But so here, our change in t, the time increased by 10 years, and the value decreased by 18,000. So our slope is the change in v, negative 18,000, divided by the change in t, 10, so negative 1,800. So that's our slope. We were given our intercept. We were given our starting value. So our value as a function of t is negative 1,800 times t plus 18,000. Or we could write the terms in the other order and say 18,000 minus 1,800t. Whichever you like better. Okay, so this is probably somewhat different than the slope formula that you're already familiar with. The slope formula that we usually meet in algebra class looks something like this. M is y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are two pairs. That really is what we just did here, right? When we're using this formula, we're thinking implicitly that y is a function of x, right? Y equals mx plus b. That's y as a function of x. And so The variable in the numerator, y, is a function of the variable in the denominator. And that subtraction is what we do to find a change. So this formula is the same as this formula. But in applications, rather than thinking too hard about what's y, what's x, just think, which variable are we seeing as a function of the other? So the value of the piece of equipment in this case is a function of the time that's passed. If I tell you how long has passed, you want to be able to tell me what the piece of equipment is worth. So change in v, that would be v2 minus v1, over change in t, that would be t2 minus t1. That gives us the slope. Put that together with the intercept, and we've written our equation. Now this problem also asked us to say, what does that slope mean? In this example, the slope means that the value of the piece of equipment changes at that rate. So the slope is negative, so the value is decreasing. By how much? Well, the slope is negative 1,800. We're measuring value in dollars and time in years. So the value decreases by $1,800 each year. And that's how we interpret the slope. That's what the slope represents in this model. That negative 1,800 tells us that the value decreases by $1,800 each year.